Everyone, Risk Must Thrive and Survive. This is a quick video, hopefully, to explain why we have sunset the way we do on a flat Earth. What you're looking at right now is one of two different ways that you can propose, I guess, a sunset. One is pretty much what we see in the sky, and we're just, sunrise is the opposite of this, but we're just going to be looking at sunset here. And we have a question that someone has asked me, and I'm going to do my best to explain why we see one versus the other. So let's go ahead and get into that right now. Here's our basic question in this video. The question is, why do we see the sun like this as it sets, going down apparently behind the horizon, which is what this person who asked me expects to see on a globe. We'll see that one more time, where it just simply gets lower and lower and lower and disappears as if the horizon is rising up. Whereas on a flat Earth, this person is arguing this is probably what we should see right here. See that one more time, where we just go down and disappear like that. This is one of the three videos which will be listed below. And the important thing about this one is this is a very good video that shows an uncut, and even they use time-lapse photography with this. It's very good to show that proof, which we know is proof, over and over and over again, is something that bald earthers will throw at you when they first come to flat earth theory. Well, how come both go over the horizon? That's proof, just like Aristotle's stupid supposed proof. If he would have used technology that was available to at his time, if he was a real scientist, which he wasn't, he would have put a little small telescope to his eye, and just like we can see today, even with a zoom camera, the entire boat or ship, whatever, that's supposedly going over the horizon magically reappears in its fullness, which proves that it is not going over the horizon. It is an optical illusion. The bottom part of the ship, sailboat, whatever you're looking at, becomes less distance between, it's hard to explain on this, so I won't, but what it is the bottom part shrinks much faster than the top to your eyes. It's an optical illusion. It's what happens at the horizon, and we're going to see that in the next two videos that I'm going to show you here, which is going to end with an amazing demonstration, I think. Okay, now you've probably seen this before, many of you. We have on the left hand side, I believe it's in Hawaii, it's camera above the clouds showing the sunrise. What's good about it is that it gives you a situation where you don't have to worry about uneven ground and mountains or different things like that. So that's what's good about the area on the left. The area on the right does have some clouds down towards the horizon, so you're going to get a little bit of a different effect, I think. But let's go ahead and take a look at this and notice the differences. Let's look at the one on the left first. And you can see as I go through this slowly, frame by frame, the sun does appear to come up. Okay, and let me go back now already. You can see the effect that we saw first, correct? Okay, let's just look at that first. It does look like it's going down below, sinking below. Now let's look at the one on the right. The one on the right really does a good job at showing you that it is heading towards you. To me, there's no doubt about it. However, it is going into what I believe to be some high cirrus clouds back there, and so it was obscured when it came above. There's a little bit of a mountainous area behind there. I can't say that for sure, but that's certainly what I would say is the cause for that. But anyway, that is more of the second event. Now, in both cases, now let's look at both of them. I'm going back and forward. You pick it up more on the one on the right, but on the one on the left and others I have shown in other videos, the sun apparently does get larger as it gets closer. We've seen it in the Alaska video, and to me, you don't need a filter to be able to see that. But that's just me, so whatever. I think we actually see a combination of both of these. We see the sun get smaller on the horizon, and we see it sink down. But this is perfectly explained and going to be demonstrated. So let's look at the perspective part of it first.
Okay, here's a little illustrator or a little cartoon from a website called timeanddate.com. It's really funny that they would have a perfect illustration of a sun rising and setting on a flat earth due to perspective. You'll notice that it rises from below the horizon and sets below the horizon. Now you might be saying, well, how's that possible? I can see now you're saying that it rises and lowers due to perspective, but how does it disappear below the horizon? Well, I got a theory about that. Because of the fact that all parallel lines and planes converge at your eye level horizon, this is according to the perspective, I'm not making this up. If in fact, and they do, they converge at your eye level horizon visually, then it makes sense that after that point they diverge, meaning they then separate. So the sun would continue on a downward track. As you can see from my illustration here, the lines would go to your horizon, and then afterwards they would spread out and separate, kind of like a starburst, and the starburst being at your horizon, at your focal point.
So we've looked at this before right here, and you can see this also explains the boats on the horizon, how that works. Remember, the bottom part disappears first. Now when you see this demonstration coming up here in a little bit, you're going to be amazed. Again, this video will be posted below so you can see the whole thing. This person does some amazing demonstrations that we're going to see in this video and in another one. But anyway, he uses a table and a coin to demonstrate the same thing. The table is on a flat surface. It shows you from a perspective of being on the edge of that flat surface, like we would be if we were standing on a flat earth, and demonstrates how the coin would look as he moves it towards the edge and away from the edge. So let's take a look at that first. So there's the coin. As you can see it moving away, it disappears from the bottom to the top. And he's going to move it back now, and he's also going to show you the top here. That's where the coin disappears from the camera view. It's not that far back, is it? So watch as it appears. It's going to start from the top of the dime first. That's a dime for those of you overseas. 10 cents here. There it is. Okay. You might be a little bit impressed now, but maybe skeptical, and then he's going to show the sun again, but we're going to skip that. Okay, here we go. What he's going to do is now he's going to use a light instead of the coin to show the exact same thing on the table. So here's the demonstration using a light on the table. He's going to be jumpy in part of it, but it's cool. Watch how it starts to get a little bit brighter just before it comes visible there and comes up, and you can go back and watch that slower, and he'll go back slower here. Amazing. That is exactly how it works and how it looks. He's using a light and he's using a flat table, and he's just moving it to the observer and then away from the observer. Now he's comparing it to the sun on the left, but I keep looking at the right side. As it starts to dawn, and there it is. Perfect. Now wait till he puts it on this tulip field. That's where he's going to be a little bit jumpy back and forth. But imagine him doing it straight here, how this demonstration works. It's going to look exactly how the sun goes across the sky and rises from our perspective. And remember, he's doing this on a flat table. So here he goes. He's slowly moving it. Like I said, a little jumpy, but that's this is fantastic. That's exactly what we see in the sky. We see it rise up. It looks like it's rising, but that was on a flat table. Hope that helps everyone to be able to explain that. Thanks. Take care, guys. Bye.